Hello, I'm Danny Ailion, and I'm here to tell you about the story of Amdocs Digital Persistent Store, which is a success story with Couchbase. A little bit about myself. I've been dealing with software for the last 30 years. It all started when I was 13 and learned BASIC, and I've been actually developing ever since. I did all the development roles, starting from a first-year student throughout a senior developer, architect, and now a chief architect of a pretty large organization. So a little bit about Amdocs. Amdocs is a very big company that gives software solutions and products to telecommunications service providers. It does a lot of things. I'm within the unit of Amdocs Technology, which creates the product. I'll tell you a little bit about Amdocs. Amdocs is a very big company that creates software solutions for telecommunication service providers. Within big Amdocs, I'm in Amdocs Technology, which is responsible for the products, developing the products before they go to implementation at the customers. My responsibility falls under the commerce and care and channel application solutions. This is a group that includes about 600 developers and 30 software and solution architects. The server-side components consist of about 220 microservices and counting. Out of them, about 150 uses persistent store and distributed cache. So what are we going to discuss today? A little bit about the Amdocs Digital journey and our platform, which is MS360, which gives the overall solution for developing on top of microservices. We'll definitely talk about the digital persistent store, how we chose our process, our thinking process, and how we came up, ending up with the Couchbase as our operational database. The main part of it is the third bullet, actually, which talks about how the advantages of Couchbase are actually being utilized in Amdocs Digital. We'll talk about some use cases, hopefully see some code, and etc. Three main features. The third bullet is the bullet that we're actually going to talk about the most, which is why Couchbase fit Amdocs Digital products. We'll talk about the advantages of Couchbase and how Amdocs Digital utilize them throughout several use cases. We're definitely going to talk about the three new features, which is the transaction management, the high density support, and collection feature. So let's go. So when we started the journey of developing in microservices, we understand that we need everything from scratch. We need to build everything and to understand how to do things in a proper way in order to support a cloud-native system. Okay, so as you see here, there are a lot of aspects in the platform. Of course, I'm not going to talk about everything. I'm going to focus on the persistent store, okay, which includes 4 areas of concern. Of course, the operational OLTP database, our archiving database, the distributed cache, and the full text search. All of those are persistent store that needs to be handled. And as you will see by the end of the session, that Couchbase answers the first 3 concerns. And currently we are evaluating even for the full text search capability. So as I said, the Amdocs Digital platform, which is called MS360, which needs to cover every aspect of developing and doing things when developing microservices, includes a lot of things. So in a nutshell, we are using Kubernetes and Kubernetes enterprise flavors like Amazon EKS, if you're going for public cloud, or OpenShift by Red Hat for an on-prem solution. All our software is actually packed in a Docker, which is deployed, of course, on Kubernetes. Our microservices themselves are basically Spring Boot application. We are actually doing almost everything possible with Spring. Spring, the Sprinkler project, and everything. Of course, we had full CI/CDs, pipelines, and everything from the single microservice to the suite level. There are multiple continuous delivery or continuous deployment pipelines all over. But again, this is the place for another session. Here, we'll talk about the persistent stores. And as you can see, there are several of those. Of course, Couchbase is the main one. We have Elasticsearch in order to support complex free text indexes. In several places, we have Postgres where we need actually relational database support. Other than that, we have Kafka, which is our message bus. We have Prometheus to do our monitoring solution, again, with all the ELK stack that comes with it. We are heavily using Prometheus. We store the both system health and applicative counters. But again, we are here to talk about persistence. So moving on. So let's talk about how we started evaluating which things to do. Let's talk about how we started to choose the persistent store. So when choosing the persistent store, there are a lot of consideration. Okay, first of all, you have to understand your business, the nature of the software that you are going to write. There are, as you can see, a lot of attributes to take into account, especially for us when we're talking about cloud-native system, scalability, high availability, robustness, reliability. All of those were super, super, super important and a major consideration in our solution. Okay, so we first of all understood what exists. Because we are writing an enterprise-grade solution, things like business support and training are also very, very important. Because we need to make sure that we have a large group of developers. They need training. They need to be able to either learn by themselves or have specific training. And this was also a consideration when we choose our database provider. So the next step after we understand the considerations, we actually looked at the families or the types of databases, the technologies, what exists in the market. And here is a little bit of summary of what exists. Because we were cloud native and scalability was a major concern, we actually focused more on the NoSQL family, but we also made sure that we are not missing anything else, meaning that there is no relational database that can suddenly scale, etc. But as we know, this is the weak side of relational databases. So NoSQL was the actual family that we emphasized. So we chose a short list out of the long list, mostly NoSQL solution databases. Okay, so now that we understood what we want, we actually went down and narrowed down the list, and we came up with three leading technologies in the database area, which is Couchbase, MongoDB, and Cassandra. And we actually looked at the enterprise edition of Cassandra, which comes with the data stacks. And for those three, we created what we call a POC. It was an actual POC. We spent 3 developers for about 3 months evaluating a lot of use cases just to make sure that we are not missing anything. So a little bit about the POC. So on the left side, you will see that the scale that we are dealing with. We are talking about big customers that has a lot of end customers of their own. Okay, so the 80 million products means like 80 million customers. And there are a lot of orders. In many of our cases, especially in Asia, we're talking about supporting 300 orders per second for a period of about 10 hours. So you can understand the big scale. This is from the business side. From the technical side, we wanted to make sure that you are covering failover, doing backup while the system is on, adding new node and rebalancing if we need to, just to make sure that everything works properly and we are not missing out on anything. So the table below, again, and this is a sum of the POC, just a summary table. You can see that the items that we check, like high availability, scalability, performance, consistency, of course, all the operational aspects, how to configure and manage the system while in production. Of course, the ease of development, how easy it is to do things, to learn things, and of course, support and documentation. So you can see the weight column, which talks about Amdocs Digital needs and weight per item. Okay, this is by no means come to represent anything else besides Amdocs Digital needs and considerations. Okay, so the table here reflects what imported to Amdocs Digital, and as you can see, we tested all of them in a practical way. Nothing is theoretical for those three, and these are the scores that we gave. And as you can see, again, in our scale, Couchbase scored the highest score. Okay, moving on. So as I promised, now we're going to cover the key advantages of Couchbase and how Amdocs utilizes it in their solution and in their environment. So the first one is cache plus persistent store bounded together. This is an excellent thing for mostly for development perspective point of view, because anything that you write, doesn't matter if it's the way you initialize your thing or the way that you query your data or get an object or whatever, it doesn't matter if it's going to a distributed cache or if it's going to something which is persisted, or what is the persistence policy. Okay, it's agnostic because Couchbase gives you a whole solution and you don't have to worry about doing things, first of all, against the cache, and only if it's not in the cache, go to the database to retrieve it, or if you're working with some data grid, you don't have to worry about all the right behind kind of thing that needs to happen. No, you do the developer writes his code, like everything is in memory and everything is accessible. And this is super easy, both for developers and also for operations, because it's actually one technology. We don't have, I don't know, for example, the equivalent can be Redis for distributed cache and Cassandra for a database. Then we saved one because we're using only one. It's a big advantage. The next one is supporting terabytes of memory. As I said, Amdocs business needs to scale to very, very high scale. Okay, we're talking about in some cases doing 450 orders per second. Okay, with a response time of around 200, 250 milliseconds per public API, which requires a very, very high response time from our database. So definitely, the more we can put in memory and actually do things in memory, the better. So Couchbase, again, allows us basically to put as much as we want out of the 2 terabytes that can be persisted in memory. We have a lot of use cases where we use at least half a terabyte, but it can grow up even to a tera and a half in memory. Again, it's all a matter of how much RAM you want to put on your nodes, but the system supports it, and this is what's important, that you can actually configure it. And again, for critical items that you need high response time and you have a lot of data and you prefer to put them in memory so you can do everything in memory, this is a huge advantage. And as I said, the Amdocs Digital use cases needs it. Next thing, consistency. So consistency is very, very important. As you probably know, when dealing with NoSQL, there are several things to choose, whether you have consistency or sometimes availability or speed. How quick is the operation that you do if you want to store something or if you want to retrieve something, or how important it is to you when you actually did a commit on an operation, you stored something in a database, and then 1 nanosecond after you're doing a retrieve of this data. Now, is it important to get the latest update, or you are good with getting something which is not the most updated version? Okay, so this is what is important in consistency. So in Amdocs use cases, it is super important to get the latest version. If something was committed, anyone that reads it, again, nanosecond after, should get the latest committed version. And again, because we are dealing with operational OLTP and not analytic system, and which in there you might want to say, okay, I'm good with the data that was committed a minute ago. In OLTP systems, we really want the latest version. And as you can see, many of the Amdocs microservices, around 100, which we called CRUD, they form the create, read, update, and delete operations, are implementing this. Most of them, again, consistency is super important. And again, major advantages of Couchbase. Schemaless. So schemaless means that there is no definite structure in a database. You actually have a document, and then Couchbase stores the JSON string of it. So whatever you have in your document is actually being persistent. And this is super, super important for Amdocs because, first of all, we have a lot of hierarchical and flexible attributes inside our objects, and they are customizable. Amdocs works in a way that there is the product division that creates something, which is the starting point for implementations to take and create their own implementations for the for Amdocs customers. Okay, that means that almost every model that we have, doesn't matter if it's a customer or an order, or a shopping cart, or an individual, they are extendable. Okay, so in each implementation, you can add more and more and more attributes to fit the regulation of this country, or again, for any need, either business need that didn't exist in the product, or whatever. So that means that you start your model with, 10 attributes, and then in implementation, you have 13, because someone added additional 3. And the schemaless property of Couchbase allows us to actually add the properties to the object, and then once we store it, those additional 3 attributes are being stored and being retrieved automatically without anyone doing anything. There is no need to write database definitions or do anything special. Everything works seamlessly because of this. And the big advantage is that all the Couchbase tools works on them. So I can write any nickel query that I want on these additional fields, or I can create an index on them and everything. So again, major advantage for Amdocs Digital. Query language. So query language is something which is really, really important for 2 reasons. First of all, any database should have a good query language in order to get the data. It's not just a cache that gets by ID. You want to perform queries. And the second thing, a lot of our existing development force actually worked with relational database and new ANSI SQL. So we wanted to have something which is relatively similar or close to ANSI SQL. And the nickel query of Couchbase actually does that. Okay, so as you can see, you can easily create an index, and you can easily perform a select query that reads according to specific conditions and parameters and everything. This example, we can see actually that we're talking about PI, which stands for the product inventory, what the customer has, and here we want to find all the related items that relates to whatever the customer have. Okay, so if I have, a TV product, I have from the service provider cable TV, and now I'm searching for what else can I put as an add-on on top of this TV. So for example, I can get Sports Pack, HBO, and other things like this, and this is the query that actually we perform in order to get this data. Next thing is cross-data center replication. As I said at the beginning, Amdocs provide enterprise-grade solutions, meaning that disaster recovery solution is built in. And it is very, very important for us to maintain the ability to have a DR, either active-active or at least active hot standby solution. Meaning that if you're working in site one and you have the data there, we want an online replication. Online meaning whenever I'm doing the change, I want it as fast as possible, this data to appear in the DR site. Okay, so so that means that if I have to move or to switch from site one to site two, or move from the active to the DR site, I can do it as fast as possible. Okay, so Amdocs works in a way that in each site we have 1+2, meaning one master plus two replicas. Okay, and when I'm doing a change on the master node, it's automatically being replicated to the replicas within the same site, and also to another node in the DR side. Okay, which is again the master node on the DR side, and once the data exists there, it's being replicated again to other to the replicas in the secondary DR. Now, of course, the user is not waiting. Okay, you can configure everything, but the idea is that we configure the commit to be one master plus one replica. Once it is done, I'm giving back the commit to the users, saying that the operation was successful for high availability reasons. Multi-document transaction. Again, this is a great feature that I was lucky enough to be involved with Couchbase to create it. And this gives us, like a relational database, the ability to create a transaction, put several documents in there, and commit them. And to make sure that either all of them are committed or none of them are committed. Okay, again, I'm not sure if you know, but this is highly not trivial for a NoSQL database. Okay, usually when you work with NoSQL databases, each document that you update or each row is standalone. Okay, so you don't get guarantee if you want to update now 10 documents in the same transaction and something crashed after 5, you are stuck in the middle. 5 were changed, other 5 weren't changed, and now you need to handle it in an applicative way. Here, Couchbase gave us the ability to create a transaction and put as many objects as we want there, and then commit them all at once. So no one sees the changes until the commit is done, and either everything is done or none of it is done. I can tell you that this is a great use case for Amdocs because in our solution, we are very open. Amdocs Digital is very open, and for every transaction that is done on any of the Amdocs Digital object, we throw an event so anyone can listen to those changes at runtime. So if an analytics system wants to get data out of Amdocs Digital system online, they can listen to the event and write the data right then and there. So because it's very important to us to throw this event, we want to guarantee that whenever we are doing a change on any of our objects, we also want to make sure that the event is changed. This is why we, in the example that you see here, we actually put in the transaction 2 objects. One is the actual object that was changed, in this case the order, and in the another object, it's the event data. Okay, now so we store them together. And of course, later on I have a daemon that takes the event object and publish them to Kafka, and of course then delete them because they are of no use anymore. But the idea is that I save both of them together or none of them at all. Moving on. High density support. This is a feature that will come in 2021, and it is very important for Amdocs because if you remember the archived database solution, meaning that I want to offload things from our operational to some archived database. Okay, so for example, orders. Okay, orders, once it's done, the system doesn't need it usually any longer besides tracking. Okay, sometimes you have regulations to keep a lot of the orders for a longer time, 3 years, 7 years, it depends on the country. So we don't want this data in the operational database because it makes everything slow and having a lot of data is never good. So we want to offload them to another database. This is what we call the archive database. And then because of the high density service of Couchbase, we can actually use the same technology, both for the operational one and the archived one. And again, because of the interface is the same, it's very easily to maintain it from operational perspective as well. The last thing here is collections. Okay, the ability to separate concerns within a bucket. Microservices principles talks about that each concern, each microservice shouldn't share persistent store with another one. And the idea is that each one has their own, so there is no way that integration is done via the database. Okay, only through services. This is a major microservices principle. Now, Couchbase currently supports about 30 buckets in a cluster. So, and Amdocs, as I told you, has at least 100, and we are growing, so it's actually even more. And this forces us today to use multiple clusters, around 4 clusters, okay, which create really an operational hazard. The collection feature allows us to actually go back to one and separate the concerns within a bucket, meaning a microservice can get a collection or like a namespace within a bucket, and this is the way, and only this microservice can access it. And by that, we can reduce the number of clusters, which saves us a lot of operational concerns. So that's it. Thank you for your time. I hope you enjoyed the session.